This is part 4 of section 1.7. I want to find the inverse of this function and the domain and the range. Well, right here, we can see that our x value is not going to be able to equal -1 because it makes the denominator 0. So the domain of this function is from -infinity to -1 union -1 to infinity. Now let's find the inverse. So instead of f of x, I write y. Now you switch your x and y. I'm going to subtract 1 from each side. Now I'm going to multiply both sides by a -1 here because I'd really like to get rid of this negative right here. And that switches the order of the subtraction here. So this becomes 1 minus x is equal to +1 over y plus 1. Now I'm going to multiply both sides by y plus 1. 1 minus x times y plus 1 is equal to 1. Divide both sides by 1 minus x. Y plus 1 equals 1 over 1 minus x. And now subtract 1. Final step is to replace this with f inverse. So the inverse function is 1 over 1 minus x minus 1. And now we're ready to find the range because the domain of this will be the range of this. So if I look here, I cannot have a 0 in the denominator here, and a 1 makes that happen. So x is not equal to 1. So the range will be from -infinity to +1 union 1 to infinity. Let's do the same thing here. We are already given a major part of our domain here. So the domain cannot equal -1. So -infinity to -1 union -1 to infinity. Now we just need to find the inverse in the range. So let's change this to y. Now switch x and y. And multiply both sides by y plus 1 to get rid of the fraction. I'm going to distribute the x. xy plus x is equal to y plus 2. Now I want to get my x's and y's on the same, my y's on the same side, sorry. So I'm going to move this over to here and move this one over to here. So I get x, y minus y is equal to 2 minus x. I'm going to factor a y out of the left-hand side to get x minus 1. And now divide both sides by x minus 1. And we get y is equal to 2 minus x over x minus 1. So our inverse function is 2 minus x over x minus 1. Now use this to find the range. And here we are not allowed to equal 1. So the range is -infinity to 1 union 1 to infinity. One thing I do want to point out here is that, we've been finding the inverse with functions written in function notation. When it comes to the applications, real-world problems, sometimes since we use variables that are logical, like C for cost and R for revenue, if you start switching them around like that, it can cause confusion. So usually in that case, we just solve for the other variable. It's the same process. You're going to see an example of that in a minute. So let's look at finding the average rate of change of an inverse function. So what we're really doing, when we're finding the inverse is we're switching all our x's and y's. And which means that we are switching our x and our f of x. The regular average rate of change function for f is f of b minus f of a over b minus a. To find the average rate of change of the inverse, it is the reciprocal of this. Remember that this is essentially the average rate of change is essentially our slope formula, which was y2 minus y1 over x2 minus x1. And if you switch your x's and y's, then your x values are on the top, and then your y values or your function values are on the bottom. That's really all that's happening here. So let's use this function and this information to find the average rate of change over the given interval. So the average rate of change of the inverse. So the average rate of change of f inverse will be b minus a and f of b, f of a. Well, let's just say because it doesn't matter which of these two values we call a and b, just so long as we're consistent. So if I call 1a and 3b, okay? So b minus a, 3 minus 1, over f of b minus f of a, 1/3 minus a negative 1, so 1/3 plus 1. Okay, that gives me 2 over, that's going to be 4/3, which is 2 times 3/4, which is 3/2. So the average rate of change of the inverse function is 3/2. Notice we didn't even really have to use this, and that's because they gave us these values. But if they didn't give us these values, then we would just take the 1, plug it in, take the 3, plug it in, get the values we need.